Right triangles is the very first topic that we'll be doing today. After that, we're talking about parallel lines and then angle bisectors. So, the very first of the unit, like 2.2 I think, we talked about what a median was and what an angle bisector was, right? Those are the ones we really cared about. We also talked about an altitude. We paid very little attention to it, but just as a reminder, an altitude is a line that starts the vertex and it hits that opposite side at a 90-degree angle. It's also the height of the triangle. Now when I draw the height of the triangle right here, it splits the triangle up into pieces. How many triangles do you see right here? Anybody see more than 2? Anybody see 3? 3? Is it true that you have a big right triangle, the whole thing, right? Then you have this middle right triangle, and then you have this baby right triangle? Every time I do this lesson, I kind of want to read the 3 little bears. You have the papa bear, and you have, right, like big millions of babies. These 3 triangles that it makes are similar. So because they're similar, you can set up a proportion to solve the missing side. So for every single one of these problems, kind of tells you right here, to make it easier to see the corresponding angles and sides, we pull the 3 triangles apart and draw them separately. So we'll be doing that today. I'm very specific on how I draw my triangles. I always put that right angle in the bottom corner. I always make the tall side go up and the short side go out. And then the hypotenuse is always on the angle. And then I draw it that way, so each triangle, it's very easy to see that these 3 pieces will go together, that these 3 pieces will go together, and that these ones will go together. Sorry, they're close. Yes? Where's the little baby triangle is right. That one.
Oh, and it's just on the back side of the other one.
Yeah.
Okay.
So what is the other one? Okay, so let's do this. You have this, hold on. You got this big triangle right here, right? Yes? So on that big triangle, the hypotenuse is across from the 90. How big is it? 25. Yes, there's colored pencils around you if they help you. If not, I don't care if you use them or not. If you want them, find one on your row column and grab it. On the big triangle, the hypotenuse is 25. The x, is the x sitting on the short side or on the tall side? If you're comparing these two, x is on that short side, right? All right? Looking at that big triangle. So I just need to like wait until pause. Okay, this right here is the middle triangle. What part of the middle triangle do I know? I only know it's the 16 on the middle triangle, right? Is the 16 the tall leg or the short leg? The tall leg, it goes right here. And then looking at the baby triangle, the blue one, looking at the baby triangle, we know what's x? X is across from the 90, it's the hypotenuse. Do we know anything else? Do we know the short side? Yeah. Is this 9? How did she get it? Somebody else. How did she get that to be 9? Kenna? It's all right, Kenna. Yeah, the whole thing's 25. We take off the 16, right? 9. Now, I'm going to ignore the middle triangle completely because I only know one of its pieces. Looking at the big triangle and the little triangle. Do I have corresponding parts that I could put together into a fraction? Yes. I'm going to say 25 from here. What will I put the 25 over? 25 over x equals what over what? Start with the 25, so I'm starting with the x over 9. It's really hard to see what goes together when it's all inside of one triangle. But when you separate them, these are both the hypotenuse. I'm going to put them together. These are both the small sides. I'll be putting them together. Now when I cross multiply, x times x, what do you get there? Is it 2x or is it x squared? X squared. X times x is x squared equals, multiply. How do I cancel an x squared? Good. To cancel an x squared, I'll take the square root. So x equals 15. Okay, first time is always a little bit rocky. Let's do it again and then I'll take your questions. Is that okay? So the very first thing I do, always, is drawing the three triangles. I'm going to make them look like this. Make it tall, short, hypotenuse. Tall, short, hypotenuse. If you put them like this, somebody, and then they, like, how do you know what's what? It gets very confusing. Always put them this way. Now looking at the big triangle, what do I know? This side is the hypotenuse. Do you know the short leg? Do you know the long leg? No. So in the big triangle, the 100 is all I know. Is that okay? In the middle triangle, looking at the middle triangle, the x is at the short or the long leg? X is the short leg. The 64 is the long. Do we know the hypotenuse? No. Good. Looking at the baby triangle. Do we know the short leg? Sorry. Looking at the baby triangle, do we know the short leg? Yes. We haven't been told it, but we could figure it out, right? On your own, figure out how long this is. How long would it be? 36. So we said that was the short or the long? Short. The long leg in the baby triangle is x. And do we know the hypotenuse? Now one of those triangles we won't use because we don't have enough information on it. Which triangle am I throwing out? Write it out one more time. Which triangle am I throwing out? The big one.
Well, we only did
Yeah, not necessarily the x, but it doesn't have two pieces. If I'm looking at the corresponding parts, well, I know the legs on both of those. I know the heights on both of those. So I don't know enough information at all on that one. When I put my corresponding parts together, I can set up the proportion. What over what? 64 over x. If I put the 64 on top, I need to put the x on top. 36. Cross multiply. X squared equals what? Big number? 4. How do I cancel a square? Square root. X equals 48. Good. Good. Oh, what did I do? Okay, try part C. Set up the triangle. I mean, just try setting up the triangles. Let's make sure everything is in the right spot. X might be taken out by the whole punch. So the X is on that diagonal over there on the side. Yeah, don't miss the X. It's in the hole punch. Look at the big triangle. What's the short side? What's the long side? What's the hypotenuse? The big triangle. It's the middle triangle. very similar to number 1. The initial problem for 1 and 3 or A and C, are they different? On part A, they give you the 16. On part B, they give you the 9. So you figure out that's a 16. Is that okay? Okay, how do these look? You got big. On the big triangle, the X goes where? Short. The 25 goes? Hypotenuse, good. On the middle triangle, the 16 goes on the tall side. Is that okay? On the baby triangle, the 9 and the X. Corresponding parts. The 9 matches up with the X. The X matches up with the 6. No, it doesn't. X matches up with the 25. There's our proportion. We don't need the middle one at all. So, 25 over X equals what over what? Good. Now, it's possible that you might have those swapped, but they should probably, and it's possible, I guess, to have them like flipped up and down too. When you cross multiply though, what do we get? X squared, 225, so X equals what? Square root. Okay, cool. Try part D all on your own then. From start to finish, can we get it? I can have 2 markers going at the same time if I know where they both are. You just can't be writing at the same time. So I'm going to come pick up my markers and I'll tell you if I want to see the fill in the big triangle, the medium, or the little. pieces to remember that this right here is a 90, right? So this x right here, is that a leg or is that a hypotenuse? It's a hypotenuse. So if I'm putting my parts together, 100 and the x, right? The x and the 36. 100x, x 36. Cross multiply that. X squared equals 3600. Then what? Square root, square root. Questions on that one? Do you feel like you're getting better at it? Do you want to do one more? Yes. Okay, try part E. Talk with the person sitting next to you. Make sure you both are on the same page. Try part E. When you're done with part E, you can come back over to your homework and get working on it. But I want everyone to know. When we're looking at this big triangle, thanks for bringing that up. When I'm looking at this hypotenuse of the big triangle, if that were a 10, we would just call it 74, right? So we'd add those two together. Is that okay? Number 24. Yeah. I think it's been going on. Oh, has it? If that was a 10, I'd just call it 74, but it's not. It's an x. How do I combine those together if I'm... Okay. Well, if it were a 10, I'd say 10 plus 64, right? But it's an x, so what am I going to say? X plus 64. Is that all right? X plus 64? Yep, so this is my 90. Across from the 90, I've got an x, I have a 64. I can't combine them together and call it 64x. That doesn't work. It's not a number, so I can't make it a number. All I can say is I'm going to take the x, I'm going to add 64 to it. Two pieces added together, x plus 64. Do we know anything else about that big triangle? Do we know anything else about the big triangle? No? Okay, let's look at the medium triangle now. What do I know from the medium? Do I know the hypotenuse? No? Do I know the short leg? Which is what? 48. Do I know the tall leg? 64. Now let's look at the baby triangle. Do I know the hypotenuse? Well, this is my 90 of the baby triangle. Do I know the hypotenuse? No. Do I know the short leg? Short leg is x. Tall leg, 48. So when I match up my pieces, yep. Fine. This time I don't have two x variables because of where the x landed, and that's fine. When I set up the proportion, x over what? X matches up with 48 equals what over what? So x is where we started, which means we need to start with 48 over 64. .48 times 48 is a big number. I don't know what it is. What is it? 304 equals, cross multiply here, 64x. Okay, we're going to move on. So we have time to work on the homework, and then I can answer your questions individually if you still have them for that section. That's the hardest part of today. After that part, everything gets a lot easier. So really quick, parallel line similarity is if I have a triangle and two parallel lines. If we know that this is a B, C, D, a line parallel to one side of a triangle splits the other two sides of the triangle into proportional pieces. That means those two can be matched up together. Those two can be matched up together, and we can write it into a proportion, A over B. Now if I said A over B, what would we say on the other side? B over D. And we can use that to cross multiply. Instead of using the whole side and then the whole side, I can use piece and piece. Piece and piece. Okay, so let's try a few of those. Wait for it. Try a few of those. So this works when they're parallel. If they're not parallel, then it's not going to work. And the reason it works is when you have parallel lines, you have corresponding angles, so the two triangles are similar. Okay, if I were to match up the proportional pieces, the 12 matches with the, or 15, it doesn't matter. 12 and 15 are fine. 12 and 20 are also fine. If I match the 12 and the 20, then the 15 and the x would go together. It could go like this. It could go like this. Both of them work. The one that does not work is this. Because this is like a little piece with the whole side. Like this is the one that doesn't work. But you could do it like this, you could do it like that. It's going to be the same. And the reason it's the same, let me get rid of this so we don't get confused. The reason it's the same is when, yeah, the initial proportion might be a little bit different, but when you cross multiply, it gives you the same outcome. All right, 12 over what? 12 over 20. You may not have started it this way. If I put 12 first, I have to put 15 first, x. 12x equals 300. Divide by 12. Now we've already kind of put these together in its matches. If I start with x, what do you put underneath the x? 12. X over 12, good. They match up. Now I started with the x, which means I need to start with the what? The 15, good. They're on the same side together. Did that go too fast? We're okay? Cross multiply? I got 180. I mean, if I got some weird answer like 0.7, I'd look at it and be like, probably not right. And if you look at it right here, like 12 is bigger, but my pink dot's bigger than my green dot, right? So my pink dot on this one better be bigger than my green dot, is it? Yeah. So I mean, there's ways you can kind of assume that you've done things right. If you wanted to plug it back in and check to make sure the fractions were the same, that's how you would check yourself, yeah. What about this one, though? What goes together? You got a question mark? You got a question mark? That could match up with the 9. You have a 12 that would match up with this missing piece right here. I don't know if it's half. If I were given markings, then yes, I could say half. If this is x, we're going to call this x. Do we feel good about that? Question mark is x. Now, if the entire thing is 28, am I getting rid of x or am I adding x? The whole thing's 28. I'm subtracting x away from it. This piece right here would be, now, what am I starting with, 28, or am I starting with x? The whole thing is what? The whole thing is 28. I'm taking off x. That would be that little piece right there. The whole thing is 28. I'm subtracting the x. X over 9. Now what do I go next? This is the only way to do it. X over 9. 28 minus x over 12. Hey, this is a really good review on how I cross multiply something like this. So I don't want anybody to miss this kind of a problem. When I cross multiply these two, what do I get? 12x. What do I have to do here? It's like I have to who gets the 9? The 28 and the x. I'm going to pause for a second. Yeah, that's true. Just don't tell anybody I told her to. Okay, here we go. So who gets the 9? 9 times the 28 is what? But you're going to think it every time you distribute now, right? Yes, you will. 9 times 28. I don't know. 252. Minus 9 times the x. Everybody gets the 9. Yeah, me neither. I don't know. Must have been. But my 7th graders could distribute. What do I do to solve this problem? Let's add the 9x first. Because I've got to get it over there. So I'll have 252 equals 21x divided by 21. And we get what? All right, let's do it again, but let's have the x be a little bit more complicated. Let's do part B and then C. So I think C's there's one that's similar to C on your homework, so I want to make sure we do that one. First of all, on your own, see if you can find the corresponding, well, is it easy? Can I say that it's easy? I hate saying it's easy if somebody's totally lost. Are we okay with that? The two little pieces, we're all right? I had a professor in college that kept telling us that things were easy, and we all felt too stupid to ask him a question because he kept saying it was so easy. So then some brave person stayed after class and said, well, what about this? I don't know what you're talking about. And apparently there was like a major typo on the paper, so you couldn't solve the problem, and we all just felt stupid because it was supposed to be easy when in fact it wasn't easy, it was his fault. Anyway, I don't like to use the word easy very many times, but are we okay here? Sorry, I'm getting off topic a lot today. Cross multiply 6, cross multiply here.
You can do
if you did this over this. Okay. So funny. Now what? So when you do that, when you cross multiply, you should still get 6 equals the 3x minus 16. The big point here is that this 3 needs to be distributed to both of those, right? If it's not, then something went wrong. So what do we get here? 3x equals 24 divided by 3, x equals 8. What about part C? If we're setting up the corresponding pieces on this one, we could put the 20 with the 2x plus 17. Is that okay? Like, that's fine. I'm okay with that. What else would we have to match up? Would we match up the 8 with this or the 21 with that? Which one's easier to find? Is it easier to find this missing piece or that one? How long is this side right here? Do you know what that is, or could you easily figure it out? Isn't it 12? Because two of them add up to be 20. So if that's 12, do we have our next match? Yeah, let's do it that way. So 2x plus 17 over what? 2x plus 17 over 20. And then 21 over 12. Are there any questions on how you would solve this from here? Would you like to see it, or can we move on? You think you got it? When I cross multiply, this is where you giggle, right? Everybody gets a 12. What would we get there? 24x plus big numbers. 304? I don't know. 204? No? 204? Equals. Sorry, there you go. And then could you solve it from there? Are we good? Subtract the 204, yep. You get 24x equals 208, 206. I don't know why. Woo. Divided by 24. My brain is not on math notes today. Nice. Okay, one last thing. Again, it should be pretty quick. So you should have no less than, maybe 15, 18 minutes to do your homework tonight. We're all going to do our homework during homework time because we don't want to take math homework almost during the weekend. That'll be accurate, right? Right. All right. Okay, let's talk about angle bisectors really quick. I'm not going to read that. I'm just going to tell you what to do. Angle bisectors, when you have one, it splits it into proportional pieces again. They could be proportional like that, but it's equally true to do this. Both of those are fine. You can either like match the triangle with itself or match the two sides and then the two base pieces. It is not okay to do this one. Is that all right? You can't have a side with a base piece. You can have two sides. Well, this one matches the side with the base piece, right? But this one's inside of the same triangle. This one matches the side with the base piece, but they're on different triangles. So this one is not okay. Those two are. Is that okay? The two, no. Yes. Somebody earlier said, yesterday, if I times this 2 by 2, I get the 4. So if I times something by 2, I should get 8. I know what that something is. What is it? 4. So if you put times 2, x equals 4, I'm going to call that enough work. You don't have to show the whole proportion. If the scale factor, this is the scale factor, if that scale factor is easy to find, just use it. The problem is the scale factor is not always easy to find. Is it easy to find out what I have to multiply by 10 to get 15? Well, I know what it is, but it's not quite as cut and dry as this one. So if you're not sure what the scale factor is, you may want to set up the proportion. Finish that off for me. I said 10 over 2x minus 6 equals what over what? Yes. And then cross multiply. Don't want anybody to miss this cross multiply. So the 15, multiply on the other side, what do we get? 30x minus, everybody gets the 15, 90, equals what? 50. Add the 90, right? Divide by 30. Let's see if there's anything weird on this one. I don't want to do part C. Is that okay with you? Oh, sorry. Yes, Ashley. Yes. Let's go over to your homework really quick. There is kind of one. Is that what I wanted? Yeah. Thanks for watching. Peace out. That's all.